In this lecture, we will talk about double buffering, which is used for smooth animation. In an earlier lecture, we saw that using a uniform variable opens the door to animation. We can call GL uniform in the display callback. We can then force a redraw through glut post redisplay. This is particularly useful when the application deals with 3D objects. To animate a scene smoothly, we need to prevent a partially redraw frame buffer from being displayed. A way to prevent the above issue from happening is to use double buffering. That is, we request two buffers. While drawing is performed on the back buffer, the front buffer is still being displayed. Once we are finished drawing in the back buffer, we simply swap the two buffers. This is how we request a double buffer. Glut init display mode. So one of the parameters passed to this function is glut double. This basically means that we need double buffering. To swap the buffers, we use glut swap buffers. It doesn't take any parameters. So the sequence in the display function is GL clear, GL draw arrays. This is where the drawing is done, and drawing is always done on the back buffer. Once the drawing is complete, this function would be executed, which would swap the buffers, and you would get a smooth new frame without any jitter. We also have the idle callback function that we have discussed already. The idle callback function specifies a function to be executed when there is no other operation to be performed. We define this with the glut idle function and then give it a name, and then we write a function which will get executed every time the system finds itself to be idle. For example, we can write the glut post redisplay function call here, which will explicitly call the display callback function to refresh the frame. So complex 3D models have thousands of triangles. We can reuse vertices while defining triangles for efficiency. GL element array buffer is used for this. In lab 5, Q4A index.cpp draws a cube by specifying only 8 vertices. It doesn't use any redundancy. 8 is the minimum number of vertices required to define a cube. It uses 8 vertices, 6 squares, and 12 triangles. 3D files are provided in a specific format which contain 3D models. A 3D model file format follows a similar convention. The headers are different for different applications, but the way 3D models are represented inside a file follow somewhat similar convention. It has a list of vertices as floats, which is the x, y, z coordinates of the vertices. A list of elements as integers that specify which vertices connect to form a triangle. Sometimes the vertex normals are also provided as floats. So hence a certain vertex can be part of multiple triangles, but it will only be written once. The vertices will only be written once.